So a couple of notes about these measures of center. I don't want to talk about the mode too much. The mode isn't as used as the mean and the median, which are by far the two most used measures of center. So I want to talk about those for a second. Now, when do you use which and what are the advantages of each? Well, let's talk about both of them here. So we'll start with the mean. That's kind of the most common that you'll see. The pro of it is that it's very easy to calculate. You just take all the numbers, add them up, divide by the number of numbers that you have. As a very easy calculation to do. And another thing that we won't get to, and you would if you took a dedicated statistics class, is that the mean comes up quite a bit in more advanced statistical calculations. So it is a quantity that's very important in doing some other statistical techniques. So it's very good that way. A con, and kind of its biggest con, is that it's heavily skewed by extreme values, and we'll call them outliers later on. But the idea is, imagine if we had this data set, and let's say that you had a small class and you were counting the number of pencils in somebody's pencil case. And two students had 2 pencils each, a student had 3, another student had 4, another student had 5, and let's say there was one more student who's maybe their parents owned a pencil factory and just had an unlimited supply of pencils on them at all times, had around 600 pencils. So what would be the average here? And I don't want to calculate it exactly, I just can estimate it. So the mean, so how many numbers do we have? 1, 2, 3, 4, 5, 6 numbers. And if we add these all together, we're going to get something around 600, not too far away from 600. So the average is going to be around 600 divided by 6, which is just, well, we'd get something just over 100, but it's fine just to say it's around 100 for our purposes. And this isn't a particularly representative number for this data set. Most of these numbers are quite low. We have 2s, 3s, 4s, and 5s, and then we have this one extreme example that's really skewing where the center of mass or the balance point of the data is, and it's at around 100. So you can see that when you have an extreme value here, it really heavily skews what the mean is, and the number doesn't become particularly representative of any of the data. Well, what about the median? Well, the median, one of its pros is it's not skewed by extreme data. You can see here the median of this data set. This is in order. So there's 6 elements, so it's going to be the average of these two, which is 3.5. And the median would be 3.5 if this number was 6 or 600 or 6 million. Remember, all you care about when in median is the order of the data. Once you have it ordered, kind of how extreme the values are on either end doesn't really matter. So the median isn't skewed by extremely large or extremely small values. One con is that it's not as useful in more advanced calculations. And another one, although I don't want to list it as a con too heavily, is it's harder to calculate. And I'll put a question mark by that, and I'll talk about why there's a question mark. So the reason it's harder to calculate, in some sense, is if you have an unordered data set, and let's say it's quite large, you can imagine it's about 100 numbers, putting 100 numbers in order from least to greatest is actually quite a time-consuming and arduous task. Just adding up 100 numbers and dividing by 100, that's not very hard. But ordering a bunch of numbers is actually quite hard if they're out of order. And I put that question mark by that because now with today's computer technology, it's a little bit easier to do with technology. So, in some sense, at least for any purpose you'll run across as a teacher, you can go to a computer and you can get the computer to figure out a median quite easily. So the con of it being harder to calculate isn't as much of a con anymore in this day and age. Let's try this problem. This is a nice mean problem. When I say average here, I do mean the mean in this case. So there's 50 people on a bus, 35 adults, 15 children. The mean height, or the average height of the adults, is 160 centimeters, and of the children is 100 centimeters. We're asked to find the average height of everyone on the bus. Now, just using kind of our number sense, we know that the average, if we have adults are 160 centimeters and children are 100 centimeters, the average should be between that somehow. But remember, there are more adults, there are 35 adults compared to 15 children on the bus. So the average is probably going to be closer to 160 than it is to 100. So pause the video now and see if you can think about how to solve this problem. Our guess is it's going to be somewhere between 160 and 100, but probably a little bit closer to 160. So pause it. Remember that a mean is just how would you fairly share the height of all, say, 35 people so that everybody was the same height, and same with the 15 children. So think about what the mean is and see if you can solve this problem. Okay, now that we're back, let's see what we know. We're looking for the mean. I'll use X bar, and I'll put little subscripts down here. So we know the mean of everyone on the bus is going to be, well, it's going to be something over 50. But I'm going to rate it, I'll rate it like 50. But I'm thinking of 50 as, well, it's the 35 adults and the 15 children. So what we need is the sum of the heights of everybody. So I'll use S for sum, and I'll just write that down. So this will be the sum of heights. So if we took the sum of heights of everyone on the bus, and we divide it by 50, because there are 50 people on the bus, then we'd get the average. We also know that the average height of adults on the bus, we'll call it X bar adult, well, that's 160 centimeters. And that is, well, there are 35 adults. And we need to sum up the heights of all the adults. So we'll call it S adult. So this S adult is the sum of the heights of all the adults. If we took that and we divide it by 35, we get the average height of all the adults. And similarly for children, X bar child, I should say, is 100. And that is the sum of the heights of all the children over, and there's 15 children. And, well, the sum of the heights of everybody, well, we could sum the adults separately and then the children separately and just sum those together. So we have another formula. And we know that the sum of heights of everybody is the same as the sum of the heights of the adults. And the sum of the heights of the children. Just again, if we sum the heights of the adults and then sum the heights of the children and add those together, well, that's the sum of the heights of everybody on the bus. And if we think about it, we have a little equation here. We can solve for S adult. We have an equation here. We can sum for S child. Then we can put them in to this equation here and get the sum of the heights of everybody and then just easily calculate our average. So let's go ahead and do that. So I'm going to solve for S adult by multiplying both sides of this equation by 35. So I get that S adult equals 35 times 160, which is 5,600. And similarly, sum of the heights of the children, multiply both sides by 15. And we get that the sum of the heights of the children is 1,500. Okay, so we have those. Let's substitute them. I'm getting a little messy out of space, but that's okay. Let's substitute these into this formula so we can find the sum of the heights of everyone. So this is going to be S equals the sum of the heights of the adults, which is 5,600. And the sum of the heights of the children is 1,500, which, if you total that, is 7,100. So let's go and put that into our equation here. So this is 7,100 divided by 50. And if you calculate that, you will find that you get 142. So I'm kind of out of space here, but we can write a little sentence. The average height of everyone on the bus is 142 centimeters. And that jives with our estimation. So we said it was somewhere between 100 and 160, but because there are more adults than children, it's going to be closer to 160 than it is to 100. It's not going to be halfway. It's not going to be 130. It's going to be closer. And 142 jives with that. So we're pretty happy that we did the correct thing. All right, let's look at this example. So this one's a little bit different. So we're given a data set with two missing elements, A and B. We're told they're positive integers, so we're not dealing with decimals or fractions. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements here. We were not told what A and B are, but we are told that the mean is 4 and the median is also 4. So we're asked, what are all possible values for A and B? And let's also say, and if there's a bigger one, let's let B be the bigger one. Okay. So this one might be a little bit tricky, but I think it's a good idea to pause the video now and think about what information you can find. Play around with this. This will take a little while. But what information can you find about A and B? Anything at all. Anything that you can get a handhold on that relates A and B to some number would be fantastic. So have a little think about that. All right, now that you're back, let's see what we know. Well, we'll deal with the median later, but we might be able to narrow down what possibilities A and B are by using the mean. We know that the mean is the sum of all the numbers divided by the number of numbers. So we know it's 4. And we know it's adding all the numbers together. 4 plus 7 plus 2 plus 9 plus 1 plus 2 plus 3 plus these two unknown values, A and B, whatever they are, divided by 9. Let's simplify this a little bit. So this is, we'll add this up. So we get 4 plus 7 is 11, 13, 22, 23, 25, 28. So we know that this is the same as 28 plus our two other values, A and B, over 9, since there are 9 data points. And, well, maybe it's a good idea to see what this sum of A and B has to be. That will narrow down our search. So maybe let's kind of treat A plus B like a variable and figure out what a possible sum needs to be. So let's solve for that. I'm going to multiply both sides by 9 to get rid of that 9. So we get that 36, 4 times 9, equals 28 plus A plus B. And the 9 that we're multiplying and the 9 in our denominator, of course, cancel. And let's subtract 28 from both sides. 36 minus 28 is 8. So we get that 8 equals A plus B. Okay. So we know that the sum of our two unknown elements has to be A and B. So let's write down our possible candidates. Remember, that A and B are positive integers. So we know they're not going to be fractions, they're not going to be decimals, they're not going to be negative numbers or 0. So we're severely limited at our possibilities. Let's make a little chart. And also remember that we're saying A is the one that, if there is one that's smaller, we'll say it's A. So our possibilities are 1 and 7. 1 plus 7 is 8, and that's the smallest that A can be. 2 and 6. 3 and 5. And 4 and 4. So our question is, well, which, if any, of these values, when we put back into our data, which of these gives us a mean of 4? So let's order the data that we have. So we have 1, 2, 2, 3, 4, 7, 9, 1, 2, 3, 4, 5, 6, 7, and the two unknowns. Good. And we just have to check each case. What happens when we put these other data points in? Well, let's do it. So if we put in 1 and 7, and I'll put them in and then I'll erase them. So the first one, 1 and 7, let's try it. So we have a data point of a 1 and a data point of a 7. So here they are in order here. And we check, what is the median here? There are 9 numbers, so it's going to be the 5th number. 1, 2, 3, 4, 5. That's the guy in the middle, 4 on each side. That has a median of 3, not 4. So that is no good. I'm going to erase those. and cross out 1, 7. That doesn't seem to work. In fact, you'll find if we have 2 and 6, so 2 and a 6, the median is still 3. So in that case, we're no good either because we're told the median needs to be 4. So 2 and 6 does not work either. So you can see here we have 9 elements. So the fifth one, the one in the middle, 3, is the one that is the median. So we need it to be 4. This does not work for us. So 2 and 6 are not a possibility. You can check yourselves, but 3 and 5 is the same thing. So unfortunately, 3 and 5 won't work either. What about 4 and 4? Let's put them in. I guess it doesn't matter where we put them as long as they're in order. Again, as long as everything's in order, you're good to go. Now let's look at what the median is. 1, 2, 3, 4, 5. There we go. So now we indeed have a median of 4. So that tells us indeed that A needs to be 4 and B also needs to be 4. So there's our one pair of values that make the mean and the median true given this data set here.